Okay, here we go. On to the classwork for 9.6, geometric probability. We're going to do page 633, 3 through 15 odds. Not a whole lot of problems. Don't think there's any reason to do more than that. And so we're just going to be going over 7, 9, and 15. Okay, here we go. We got an example of all three types using line lengths, angle measurement, and then area. So number 7 is another one of those kind of word problems turned into line lengths. So let's take a look. It says a bus comes to a station once every 10 minutes and waits at the station for 1.5 minutes. And so if we want to express that as a line, we have a line. And here's where, for me, at least I would get confused and want to be careful, is it says the bus comes every 10 minutes and waits at the station for 1.5 minutes. Now, at 10 minutes, when it says comes once every 10 minutes, that includes the 1.5 minutes that it's waiting. So we're talking about a total cycle here of 10 minutes. So the entire length of time is 10 minutes. It's not 10 minutes plus 1.5 of waiting. In that 10-minute cycle, the bus is there, and for 1.5 minutes of that time, the bus is waiting. Leaving, you can do the math, 8.5 minutes of no bus, okay? So there's no bus here. Okay, so we're on the 10-minute cycle, so you want to pay attention. If it said there, for 10 minutes there's no bus and then it shows up, that would be 11.5. But again, it's on a 10-minute cycle, so that means our total length is 10. 1.5 minutes of those is the bus sitting there picking people up. 8.5 minutes is there not being any bus there at the station. So that setup is one reason I wanted to go over this question, because that is not necessarily how I would have seen it when I first read the question. Okay, so the number 7 says, if you go to the bus station 20 times, predict how many times you will have to wait less than 3 minutes. Okay, so this is a little bit of a complicated question. First of all, they're asking for what happens if you go there 20 times. The key to answering that is, well, I need to know my probability. If I know my probability, then I know how many times out of that 20 I'm going to wait less than 3 minutes. Okay? So let's find our probability. So we got to look at our line and say, well, what's the probability of waiting less than 3 minutes? Okay, so that means, let's look at, we have a total of 10 minutes here. So we know that's going to be our denominator. I've got 10 minutes. So let's go ahead and put that. We know the total is out of 10. But how many minutes out of those 10 are we waiting for less than 3 minutes? Well, for 1.5 minutes, I'm not waiting for the bus because it's actually there. So that means over this 8.5 minute span, how many minutes are only waiting for 3? So yeah, I could basically segment off another piece of this and say, here's where I'm waiting for 3 minutes. So that means there's 5.5 minutes here where I'd be having to wait too long. But 3 of the minutes, or when the bus is there, this is when I'm not waiting extra long. So that might be the benefit of looking at it this way. If not, don't use it, but if you can do it in your head. But I've got 3 minutes that are okay, because it's 3 minutes or less, and 1.5 minutes because the bus is already there. So that's giving me a total selected or event length of 4.5. So the probability of waiting less than 3 minutes is the 3 minutes and the 1.5 in which the bus is actually there, for 4.5 out of 10. So now we can go ahead and calculate our probability, which again, that's just going to move the decimal, 0.45. Okay, it's a 0.45 probability, or a 45% chance of not having to wait more than 3 minutes. So that's, if it was asking for the probability, we'd be done. With a problem like this, they want to say, well, out of 20 times, how many times will this happen? Well, that's what the beautiful probability is. We didn't just take the probability and multiply by the number of occurrences. We want to know out of 20 times, what is 45%, or 0.45 of 20. So we can just take 0.45 times 20, and we can see we get 9. So that means out of 20 attempts, or 20 arrivals, out of 9 times, the bus will either be there, or we'll only have 3 minutes to wait for it. Notice again, you can also see the correlation. 0.45 is close to half. This is close to half of 10. And so it's almost half of 20. So just one less than 1 out of 2 times you arrive at the bus station, you're going to wait for 3 minutes or less. Okay? So notice again the setup. And then they're going to love to throw these problems at you where you have a certain of negative time and they want to find, well, what if it was 2 minutes of less or 5 minutes or less? You can see how we handled that. We just selected for 3 minutes. It's like 3, 2, and 1 were all part of the selected category. Anything more than 3 was not selected. And so then that gave us our numerator. Total time was 10. Gave us our decimal. And then if they ask it out of how many times, you just multiply by however many attempts that is. It's like if you have a 1 out of 2 chance of something happening and they want to know, well, out of 100 chances or 100 attempts, what's going to happen, you can just multiply that probability by the number of attempts. So we get 9. Okay, number 9. Much simpler. Number 9 says, what's the probability that the pointer lands on orange or blue? Okay, well, blue is this 90% one here, and orange is this 45-degree one here. Sorry, not percent, but degrees. So there's our total degrees. 45 plus 90 is our probable of this happening. So that's 135 out of our total degrees, which is always what? Yes, Jeremy, 360. Missed you, Jeremy. Okay, and so this one's going to take us just a few seconds. 135 divided by 360, 0.38. So approximately 0.38. Okay, or 38%. You can see if you're looking at your answers in the back of the book, they've decided, and again, to me, they're kind of random in this, so that's why I just keep doing it consistently. They leave this as a simplified fraction. So if you simplify this fraction, you can get it reduced to 3/8. And so that's the answer they have in the back of the book. If you're ever taking a test and you get this, and then you have all these fractions as possible answers, well, what I do is I just say, well, I would just quickly crunch those answers on a multiple choice and say, well, 3 divided by 8, check it. Oh yeah, that's 0.38. In order to find, whereas if there's an answer on the test 2/5, you'd go 2 divided by 5. Nope, that's not what I got. I got 0.38, not 0.4. So they get 3/8. I think, keep it simple. This is how we solved it. And then you can check to see if your answer is right using your calculator. Okay, selected shaded region over the total possible region. These spinner ones, pretty easy for the most part. Okay, 15. Now for the area. 15, I think 13 is pretty basic, but 15, it says how are you going to find the probability of hitting the part of the triangle that does not include the square, triangle, trapezoid. So they want this region, L, the negative space, everything behind the shapes. Okay, so you can see this is just going to be only complicated because it's a multi-step problem in that we need the selected area is the full area minus the 3 shapes. So we're going to have to find the area of the 3 shapes, subtract it from the total area, and then that will give us our selected area. So the work on this one is finding that selected area because it's going to just take a few steps. So I didn't write the tiny dimensions in here. I'll just read them out of the book. But our triangle has is 1/2 base times height. It has a base of 10 and a height of 10. So this is our triangle. I'll draw a little shape there. Isn't that pretty? Okay, our triangle, 1/2 10 times 10, so that's half of 100. So the area of the triangle is 50. Okay, our trapezoid, I'll put it down here. I don't know why I started drawing these little shapes. Just want to do some coloring with you. Area of a trapezoid is 1/2 the 2 bases added together, which are 12 plus 18, times the height, which is 6. Okay, so we can calculate that. That's 30. Half of 30 is 15. 15 times 6. We get 90. So the area of our trapezoid is 90. And then the area of our square Got to be consistent. Stick with it. Look at that beautiful shaded square. The area of our square is just base times height, or side squared, and the side of that is 10 times 10. So then the area of the square is 100. Not hard, easy areas to find. So the space we're not trying to count is these three combined. 50 plus 90 plus 100 equals, what was that, 240. So we're not trying to find the area of 240. Kind of a funny way to put it. So we need to find this red space, we need to subtract this from the total area. Another way we could do it is we could find the probability of hitting this and then flip and just subtract from 100, which would be the opposite probability. That might be another way to do it. Maybe we'll do that at the end of this. But anyway, let's find the total area of the rectangle. Total area of the rectangle is area equals base times height, 48 times 24. And its total area is 1152. 48 times 24 is 1152. So, again, multi-step. That's why what I think makes this one tricky. So we're going to go 1152 minus 240, and that gives us 912. 912. So there, after adding up all the shapes, subtracting them from the total rectangle, we can see this red shaded region is the space not with the three shapes is 912. So we're finally ready to set up our fraction. 912, running out of space, of course. Do it right here. 912 over, then what's the total possible? Well, that's this number right here, the entire rectangle. So over 1152, and now we can calculate that. 912 divided by 1152, we get 0.79, or 79%. Okay, so we have a 79% chance of hitting one of the non-shapes, which if you look at the picture, you can see that most of the area is not in the shape, so that makes sense. We have a pretty good percentage chance or likelihood or probability of hitting this shaded region. Okay, for those of you interested, because you're math masochists, but another idea that might have been a little faster is because I had this number 240, I could have found the probability of hitting these three shapes and then deduce the answer from that. In other words, I could have quickly just said, okay, 240 of the shapes out of the total 1152. And so we can do it that way. 240 divided by 1152. And you can see that comes out to 21.21. So I could have said, okay, I have a 21% chance of hitting the shapes. That subtracted from 100 is 79. So that means if the probability I'm not looking for is 21%, then the probability I am looking for of not hitting the shapes is 79. So that would have been an alternative way to solve this problem. And just keep that in mind, because sometimes it might be faster to find the negative probability and then say, well, that's the opposite of what I want, so let me just subtract that from 100, because these are out of 100% chance of attempts. And so that would have been another way. If that confuses you, again, erase that from your memory banks and just stick with what we did here. Okay, classwork 9.6, problems 7, 9, and 15. Please reach out. I would love to help you. Take care.